Okay, Algebra 2 Pre-Calc, folks. This is part 2, some more analyzing polynomial graphs. Just a couple of examples. Here is a fine specimen of a polynomial function. F of x equals negative x to the fourth minus x cubed plus 4x squared minus 5. Okay, so I am going to my graphing calculator. Y equals is right up here. That's where I'm going to touch to go to where I get to type this equation in. And then don't forget, instead of the minus, use the actual negative, which is down here. So negative x, and I'm going to go ahead and move it up a little bit so that you can see what I'm typing. X to the fourth, that's using this caret button in the 4. You can't see what I'm typing, there it is. The caret, so I typed negative x to the fourth. Then I'm pressing right arrow to get out of the superscript because it was up there with the 4. Minus x to the third plus 4x squared is over here minus 5. Now, actually, this is what happens when you don't look at your screen. See this? I didn't press the right arrow to get out of the exponent there, so all of that got typed in the exponent. So x to the third, let's get rid of all that. And then I should have typed the right arrow to get out of the exponent again, and then 4x squared minus 5. So here it is. Now I'm going to press graph, or I could press press zoom 6, because zoom 6 is the standard window. If you press zoom and then just press the number 6, you don't have to arrow down. It'll give you the standard viewing window, which is from negative 10 to 10 on x and negative 10 to 10 on y. Okay, so here's the basic shape of my graph. All right, so I'm going to go ahead and just sketch it a little bit off to the side here. I don't know, it's not, well, I could go ahead and, I can go for a final sketch. Let's see how well I can approximate what I saw there. It has a bump that comes up here, and then it goes across the y-axis here, and it looks something like this. It might be easier for you to sketch a little sort of small side graph to it, put everything on there, and then actually find the points, and then actually go back and plot the points first so that you make sure your graph goes through the right places. I'm hoping mine's pretty close right now. So finding my points, I want to find the x-intercepts and I want to find the maxes and mins. So I'm going to start out and I'm going to find the maxes and mins. By the way, you could say maxima and minima, or you could call them both extrema. Extrema means all of those. So it looks like I've got a max here, a local max here, a local min here, a local max here. This local max is not only max for the local area, but really it looks like it's an absolute max. Okay, so maximum, I pressed the number 4. Remember again, I pressed second trace, pressed 4, and then I'm going to go over, arrow over to where I think that mountaintop is, and go to the left of it a little bit, press enter, because it's asking me for a left boundary. Then it's asking me for a right boundary, so I go to the right of the mountain, press enter, and then for guess I can just press enter. And it tells me that that max is at negative 1 point, and I'm going to switch to just using tenths here, negative 1.8, 3.3. Negative 1.8, 3.3. Okay, let's go ahead and find the other max. Second trace, max. And the other max is over here, so I'm going to come over here and go down to that little mountain top and go to the left of that mountain top and press enter for left boundary, then to the right of that mountain top and press enter for the right boundary, and that one's at 1.1 for x and negative 2.95. If I'm rounding to tenths, negative 2.95 actually goes all the way to negative 3. So it's 1.1, negative 3. Now I've got a min right in between there, second trace, minimum is 3. And I'm going to go to that little valley and go on the left side of the valley and press enter for left bound. Go on the right side of the valley and press enter for right bound. And my minimum is at, now be careful of this, it says 4.7817E negative 7. That really means 0. The reason that means 0 is because that number, 4.7817E negative 7, means 0.00000047817. So in other words, it's 0. The reason it's not exactly 0, the reason it doesn't say exactly 0 is pixels for the calculator. So that really is 0. So 0 for x, and y is negative 5. So this is actually the y-intercept, and it is a min. Sorry that it looks like mine goes down below there. It shouldn't. So that's actually an argument for waiting to draw it until you know where the mins are, or the extrema. Now for the zeros, I'm going to press second, trace. 0 is 2. So left boundary means I have to decide which 0 I'm trying to find. First one I'm going to go from left to right. So I'm trying to find this one on the left. I go to the left of it using the left arrow, press enter. Move to the right of it using the right arrow, press enter. And then for guess, I get it. And here you notice it's got 1e negative 12 for y. That means y is 0 because that's 0.00000000001. So this, my x is negative 2.3 and y is 0. Okay, and let's find this 0. So we've got to the left of it is here, then move to the, ooh, I just hit something crazy. Let's just go back to my graph. Second trace, 0. To the left of it is enter. To the right of it is here, enter. And my 0 is at negative 1.1, y is 0. Okay, so here are all my key points that I care about because this one actually also serves as the y-intercept. So it's a min and a y-intercept. So let's look at what I've got. I have a local min at 0, negative 5. Technically, that's a minimum value of negative 5. I have a local max at 1.1, negative 3. Technically, the value there is negative 3. That's a maximum value for that area. So really, for min and max, we're saying minimum height, maximum height. I have an absolute max at negative 1.8, 3.3. In other words, the y value 3.3 is the highest this graph ever goes. So as soon as I see that, if you have an absolute max or an absolute min, that tells you that your range has some restrictions on it. Otherwise, your range is just all real numbers. But this graph is never going to go any higher than this. So we're saying that's the limit, the y limit. It goes up to that point. It's like a ceiling. So my range is from negative and infinity up to 3.3. And I'm going to go ahead and write the domain. Domain is all real numbers. All right, what have I got left to do? I need to do my intervals of increase and decrease. Let's look at how many turns my graph has. I've got a turn here, a turn here, a turn here. If I have 3 turning points, that means my graph has 4 sections, 4 chunks that I need to talk about what's happening. You always do interval of increase and decrease as if somebody is walking on top of your graph from left to right. So here's this guy, he's climbing a mountain, so that is an interval of increase. So my graph is increasing from the beginning of the graph, which means from negative infinity. On the left side is negative infinity. I'm only going to use x values here up to negative 1.8. That's increase. Let's see if I can color coordinate. This is an area of increase, an interval of increase, and then it's also increasing here as well, walking uphill here. So that's my other interval of increase, is from 0 to 1.1. Then I have 2 intervals of decrease. I have an interval of decrease from here downhill and also from here downhill. So I've got In decreasing, can't see it, but I'll move up in a second. From negative 1.8 on X to 0, and from positive 1.1 to positive infinity, to the far right side of the graph. Negative 1.8 to 0, and positive 1.1 to infinity. Okay, those are my intervals of increase and decrease. And I think that hits all the high points that I needed. Oh no, in behavior, last thing. In behavior, I can see that it points down on both sides. That means on the left, which that's just a way of saying on the left, as x approaches negative infinity, my graph points down. As x approaches positive infinity, my graph points up. Okay, that is my end behavior. End behavior. Notice that if my graph did not, okay, it's pointing down on both sides, sorry about that. Notice that if my graph did not point down on both ends or up on both ends, if both ends weren't pointing the same direction, then I wouldn't have anything to say about the range. Because if the two ends of your graph point in opposite directions, that means it's going up forever and it's going down forever. The range is just all real numbers. The only time your range will be limited is if the ends are both pointing the same way, which means you automatically have either an absolute maximum or an absolute minimum. If they're both pointing down, it's an absolute maximum. If they were both pointing up, it'd be an absolute minimum. And that is related to your range. All right, next one. Bam. Okay, let's put this in the graph. And if you haven't been doing this, this might be a really good opportunity to go ahead and just pause the video, stop, try it yourself, see if you can put everything, and see if you get all the same stuff I do in a little while. You can even skip to the end to check yourself and then not bother watching the video if you got everything, because you don't need it. So here you go. Pause if you need to. Okay, so this is sort of like a W shape. So looks a little like this. So let me go ahead and find the max and mins. How about that? The extrema. Move to the left, move to the right, and press enter. And I get negative 1.3, negative 5.5. Then second, trace, max, move to the left of my max, press enter, move to the right of my max, press enter. And for guess, don't forget to look. It needs to actually say maximum on the screen or you're not done. If it says guess or left bound or right bound, you're not done with the process. So maximum 0.16. This is why I did this. It kind of looks like that max might be on the y-axis, but it's not. So I'm glad I didn't draw the axes yet. That's why I didn't draw the axes yet. It's because I was concerned that it wasn't on the y-axis and that I was going to put it there. So 0.2 and negative 1.9 is that point. Then let's do this last minimum over on the right. To the left of the min, to the right of the min, press enter, and my min is at 1.1, negative 3.1. 1.1, negative 3.1. Sorry that is actually a decimal point. It looks like a comma, but it's a decimal point. So my y-axis comes in a little bit to the left of this guy. Okay, so now let me go ahead and figure out what the x-intercepts are. I'm going to go ahead and draw this like right here. There we go. That looks about right. Some space between here. All right, the x-intercepts are zeros. Left bound. Let me get over to the left one. I want to go left of the left one here. And that's enter, and then right of that one, enter. And guess, negative 2, and again, with the whole scientific notation thing, that's a 0 basically. -2, 0. If you put that whole scientific notation thing, that's wrong. Don't do that. You need to recognize that that should be 0. Partly because that's what we're trying to find is the zeros, which means where y equals 0. Now let's go find this one over here. And we have 1.750, so this is at 1.80. Notice that because we're looking at the graph, I'm sorry, that's positive 1.80. Because we're looking at the graph, we're not finding all the zeros, we're finding the x-intercepts. This thing has 3 terms, so the smallest degree it could have is 4. Well, we already know it has degree 4. If it has a degree of 4, it has 4 zeros, so these two are the only 2 real zeros. The other 2 zeros would be imaginary. So I have found those now. So I'm ready to go ahead and start listing things. I have a local minimum at 1.1, and that local min is -3.1. I have a local max at 0.2, that is -1.9. I have an absolute minimum over here, lowest point for the whole graph, at -1.3, which is -5.5, meaning the lowest y value you will ever have for this graph is -5.5. So that means my range starts at -5.5 and goes to positive infinity. Okay, remember interval notation, it's always smaller number to larger number. So the smallest number you're ever going to have is going to be on the left, positive infinity on the right. Domain is still all real numbers. Okay, I'm ready to do my intervals of increase and decrease here. If I have 1, 2, 3 turns, I'm going to have 4 sections of my graph. So let's see what's happening here. Starts out going down from left to right. So this is an interval of decrease, and then there's another one over here. So I'm going to describe both of those orange intervals as intervals of decrease. So this is decreasing from -infinity to -1.3, and also from 0.2 to 1.1. Only use x values for intervals of increase and decrease. And then it is increasing here and here. So increasing from -1.3 to 0.2, and from 1.1 to positive infinity. It keeps going forever. I started to look at this and think I needed to put that, but that's not a turn. That's that x-intercept. So it keeps going forever up. It's increasing forever at the end. So those are my intervals of increase and decrease. And last but not least, I have end behavior. My end behavior, because both ends are pointing up, I have as x approaches -infinity, f of x approaches positive infinity, it points up. As x approaches positive infinity, f of x also approaches positive infinity, meaning it points up. And that is all.